everyone. Guys, this is the first time we've met. Love to, tell me a bit about yourself, who you are.
So a bit of background. I've come from all walks of life in terms of commerce, engineering, supply chains. Really had a pretty amazing opportunity to see a lot of different industries. In the past sort of 3 years, 4 years, I've been mostly focusing on manufacturing and the development of hardware products. Kind of always grew up around it. My dad's a mechanical engineer. He has a collection of steam trains. I grew up machining parts in my basement. So that's where sort of the passion was kicked off for me. And then I realized more and more as I went into the world, understanding how outsourcing and everything else worked in the manufacturing in Southeast Asia, I really started to foster a love. And subsequently, we ended up building a 1.5 ton machine tool from scratch and actually running our own machine shop.
Fantastic.
Yeah, so it's been a really interesting journey even before the startup.
Where was that?
So the startup started in around 2020, 2021. I think that's when we first met you. But we were running the machine shop for a full year before that. So we onboarded a whole bunch of industry mentors, anchor machine tools. Everyone thought we were a bit mad building a machine tool from scratch. But it's also what gave us a lot of the fundamental understandings of our industry.
So one of the reasons I think you guys not only just know the algorithm and AI, you also know the machining.
Yeah.
So that's a very rare combination.
Yeah, so I think for a lot of these complex problems that are having to be addressed and solved today, whether or not it expands from biotech to manufacturing and to electrical engineering, I do believe that you need an intersection of skill sets where you understand the fundamentals, not only from the practical side and getting your hands dirty, but also from the business side. So from us, we've done hardware development, we've done sort of med tech design, prototyping. So two of my co-founders are actually mechanical engineers. So they've seen how they design and how the sausage is made. But you need that intersection of practical experience, understanding how it works in the world today, and then having the software basis.
Maybe let's start back to tell us a little bit about AI at Sea.
Yeah.
What it actually does and how it relates to sort of that intersection of software, hardware.
Yeah. AI&C, what it's trying to do is create simulations of how manufacturing works in the world today. One of the analogies I generally probably overly use, the problem we're solving is engineers and manufacturers, a bit like architects and builders. So architects design things and they're not necessarily sure how it's made. Always the classic thing that blows out your budgets and lead times for these projects is disagreements and disputes across, this is what I designed. The builder goes, I can't build this, and this is how it has to work. And that really happens in mechanical engineering and manufacturing. Today, what happens is the engineers sit on one side of the world and the manufacturers sit on the other side of the world. And there's been a lot of outsourcing. And what's happened is this huge divide in a skills gap between the parties because the process is so opaque. So what we're coming in and trying to do is simulate how the parts get made so we can tell the engineers right at the start of the process if it can be made, how it will be made, what's driving the costs, to speed up a lot of those relationships.
I like how you use the property analogy because we're in Australia. But how does it feel as a founder innovating in the manufacturing sector, which arguably we don't have much of?
So in terms of, I think Australia is a really unique place to be trying to build this solution. There's only sort of 2 other companies in the world trying to deal with this problem. But because we're so close to Southeast Asia, it really helps us tap into the manufacturing side and understand that cultural demographic. Like obviously Melbourne's quite multicultural. So it really does help with the lens of understanding, how to deal with Malaysians or Chinese or Thai. But building in Australia has its own unique benefits, right? We do a lot of complex design in Australia. And the more complexity, obviously, the more difficult it is to get made. So the more problems and sort of the bigger the opportunity.
Also, Australia have a history of advanced.
Yeah. And sadly, a lot of it's been ripped out, right? So a lot of our friends are actually like 60, 70-year-old machinists that came from like the Ford automotive company. You started off in trade and then some of them went into engineering and all of those expertise left subsequently because we just couldn't afford it. As globalization happened, this is what ended up happening. I think the unintended consequence of outsourcing really was the loss of the practicality of how things get made.
Yeah.
So the people now designing those things don't actually understand that.
Do you think like the manufacturing in Australia will kind of bring some kind of this kind of a capability back, or especially leveraging AI technologies?
I think we can definitely bring back a lot of the complicated design work and start to become the innovators in hardware again. I believe that's sort of a capability, just because we are so knowledgeable, have so much exposure to industry. Most people don't actually know what we manufacture in Australia.
Yeah.
We do everything from, the F-35 jets to some of the most advanced medical technologies. I was actually in Tasmania recently, and I found out that there's a manufacturer of the world's fastest and biggest catamaran for that ferries people, right? And he's leading the charge for electrification of ferries all around the world. And we have a lot of these amazing designs, but I think it's been an industry that's been previously ignored over financial sector and legal and those aspects. Currently, hardware products are all around us and they solve physical problems in the real world. And I think for the last 20 years, most of the investment and how we've been looking at investing in the space has been focusing on service-based products, SaaS, it's all the rage, AI agents, things like that. And there's been a really distanced approach to looking at, tangible objects as high risk, opaque process, and I think that's shifting.
This is a difference, I think, between the Chinese investor and Australian investing. Is in China, there's a lot of investment going into the industry hardware, but especially in venture capital. But in Australia, venture capital is sort of framed around SaaS, AI, software. Do you have any insights on?
That's actually quite a complicated.
Yeah.
In my case, the first is like the digitalization in the B2B space, in the business space, haven't really get as mature as each other. So although in the consumer space, they are so advanced, like lots of real-time payment the kind of things, but in the business space, it's not there yet. So that's why the B2B SaaS is a little bit behind. And also there's another reason is like the competition in China or probably in Eastern Asia or in Asia is quite intensive. So if the moat is low, which most of the time for software companies, then it's very easy to be copied or to you can't really compete with others. There will be multiple companies coming in to compete. So that's why people always, investors in China, when they see a deep tech, they like to see that has a deep moat or high moat.
I think they value that because from my observations and working with Chinese manufacturers, it started off as simple. They continuously reinvested in the space. They built their expertise. They built their moats. And this is why you see China now leading the innovations in battery technologies. And through vertical integrations, they now have BYD, which is one of the most amazing car companies today. They have a huge respect for industry. And I think that's sometimes overlooked in Australia. The B2B SaaS aspect, I can understand from an investor's perspective. Generally, people will reinvest what made them money traditionally, or where they built their wealth. The issue is that when you start to look at hardware products and some of the B2B more complicated SaaS space, like construction, things like that, it's only just starting now where people are starting to get excited about this space because they can understand it. I think manufacturing still wouldn't say the hot topic yet. People like to flash around made in Australia, but no one really even understands what Australian capabilities are, which I find fascinating.
In your view, what do you think are Australia's core capabilities? From a manufacturing perspective, I'd be really interested.
So the hardest part, obviously, manufacturing in Western countries is the wages and the labour costs. So generally, what we focus on is either splitting off the design work and having it completely separately and then outsourcing to China or Southeast Asia, or we do the most complicated aspects of manufacturing. So when I gave the example of aerospace, everything that's complicated in terms of, from building trains to planes to high precision medtech equipment, that's what Australia's been best at. The other bucket that we do is we're so far away, right? So anything large and bulky, we have to manufacture ourselves. So if you're in a mine in Western Australia and something breaks on your truck and you have to, one of the, the coal shipping trucks. Yeah, well, you have to have on-hand those combinations. And there are a few big hardware companies that have been developing amazing technologies like the catamaran that just no one even knows because we don't sell to our own market, I think is one of the other big things, right? The demand is coming from overseas.
Yeah. Yeah, that's an interesting observation. Also, I feel for Australia, I'm not so sure whether people notice in the old iPhone, in the back, it's actually said designed in California, but manufactured everywhere.
Yeah.
Many in China, but now in multiple sites.
Yeah.
But it could be like designed in Australia or in Sydney, in Melbourne.
Exactly. But I think for that, there's sort of two camps that we've seen appear and have optimized for. You've got vertical integration, and then you've got almost pure outsourcing. The best hardware companies today have started vertically integrating their core design features. So, right, if you look at Tesla, they probably pioneered it, where the design engineers had to sit with the manufacturers and understand how things are going to get made. And the manufacturers can basically tell them why they can or cannot do that. And that allowed them such a high speed and iterative design process. They could bring things to market at a much higher quality in a much faster time period than anyone had seen before. So I think that's now coming back into fashion a bit, but there's huge capex involved in that, right? And that's what we're trying to solve. Having that manufacturing experience, not having to sit on top of the manufacturer, but to have it sit with you as a software package.
Yeah, I guess even like within their organization, communication between the two departments, like the manufacturing and the design, it was still, although it's within one organization, it still takes time. It's still lots of iterations, I guess.
It's a really difficult relationship because fundamentally the engineer's job is to design hardware products to solve a problem in the real world, right? It's not his job to make the parts, and it's not his expertise or forte. But ultimately, the decisions he's making does have that impact. And for the manufacturers, it's really hard for them to understand how their product that they're making or the piece of the assembly fits into the bigger picture. So the manufacturers can't provide feedback because they have no idea what it's going into or how it's going to function, what are the constraints and limitations. So what incidentally ends up happening is the manufacturer just makes it work and makes it function. Right? So the engineers end up sort of throwing all of the problems over the fence. The manufacturers will just fix it for them and it will come back. But the issue is that continuously creates an ever-increasing divide of expertise where the engineers don't understand what's happening on the other side.
Do you want to talk about how you guys solve this problem?
Yeah. So fundamentally, the things you have to understand about our industry is, so we focus on CNC machine tools, which is computer numerically controlled. Basically what this means, we focus on a technology called milling. What this really is you can think of it as a spinning, it's called an end mill for subtractive manufacturing. You can almost think of it as like a spinning drill that is on a robot arm that can move around and remove material, right? This technology has been around for a very long period of time, and it was interesting understanding that computer numerically controlled came about purely because they didn't have enough machinists. And we're going through this step today. So understanding the manufacturing side, and then you've got to understand the design side for the engineers. It's called CAD software, computer-aided design. Basically, everything from the 80s onwards is now modeled in CAD. It's everything in your pocket, your phone, everything that pretty much hasn't grown out of the ground has been 3D modeled, right? It is an amazing and powerful technology, but it does not put any restrictions on the designers to what they can and can't do. I can design, an infeasible rocket that will never launch, will never be able to be machined, but that software will enable that. So what we're trying to do is basically simulate how the parts will get manufactured and then provide that context and those limitations on the engineer as he's designing that. So he can understand, can I make it? What's driving the complexity of my part? And how can I improve this design? So that's on one side, and on the other side, we're helping the manufacturers with the estimation process. So understanding before they even start doing the work, can they make it? Do they have the capabilities on hand? Because that has a huge impact on lead times.
This is kind of like your current, your ultimate ambition in this area, how you want ANC want to be in the thing.
I think all startups start off with this big dream where you're pre-product, you think you can take on the world all in one go. Mm-hmm. And funnily enough, that's actually what our company's name is, right? AI&C, because we wanted to do automation of manufacturing. What we came to realize was we already have manufacturing automation in some regard. There are robots. Pretty much all of the physical work has now already been automated, but no one can use it because we don't design for automation. So what we envisage is the mechanical engineering entire industry starts to adopt software solutions, not too dissimilar to what the Electrical Engineering Society did about 20 years ago when they started making semiconductors.
Yeah.
But seeing that happen in the mechanical industry, right, where you can start to account for all of the different manufacturing methods. You don't have to go through this trial and error process and really reshape the way we develop and build products today.
I always like to think of engineering as a process like constraint optimization. So you're essentially communicating the constraints to the designers.
Yeah. Yeah. So, and one of the fun ones we've been kicking around now in terms of some of the phrases is we're trying to make hardware as fast as software to develop, right? Because traditionally the only way you can build hardware is, you do the first design, you get it manufactured, it comes back, it works or it doesn't. You keep doing that as the refinement optimization process, right? And in software, you have tests, you have all this infrastructure today that can, before you even go live, you're going to know if it works. And it really hampers mechanical designers and design engineers to be able to build these products without having the assistance of software technologies like ours.
Maybe just to break it down to the basics as well, you mentioned you're working in the field of subtractive manufacturing.
Yeah.
3D printing, additive manufacturing is I think, a hot word and something that we teach in schools.
Because that's slightly terrifying that they teach that in schools. So additive technology, like 3D printing, metal 3D printing, is more a competitor to some of the older and traditional manufacturing methods, such as casting. So casting is, you have sort of two parts of the mold, you stick it together, you pour in metal, and it comes out with a shape. Ultimately, 3D printing and casting need to be post-processed. So what that really means is everything that comes out of them is quite rough, and you need basically a polishing method, which is the machining that we're dealing with, right? And what people don't understand about 3D printing is that it has the same design constraints as any other manufacturing method. One of the difficulties it's facing is there's no standardization in the industry today. So every different 3D printer has different rules as opposed to all the other manufacturing methods. Here's your rule of thumb. That hasn't happened in 3D printing. So the only things we really see amazing use cases for it these days are unique internal structures of parts for aerospace tech, but normally quite niche applications, or as a replacement for castings. You don't have to remove all of this material to get to the part you need. So subtractive, really old school. It's, I think, one of my funnest fun facts is Tesla has been saying that they've invented the gigacast for their cars. That's not right. It was invented back in for steam locomotives. They used to cast the entire, pretty much, boiler for steam trains, and it's always been a methodology that we've basically, sculpting is a subtractive manufacturing method, right? You have a block, and someone chips away at it and reveals an amazing, the statue of David. So what we're doing for our world is, pretty much every machined part, everything that you touch and engage with has been gone through some version of subtractive manufacturing. I think one of the things that is quite exciting but quite terrifying is the excitement that's going into manufacturing. It comes at the cost of, the reverse of globalization. And I think that's probably one of the biggest reasons why we can solve this solution today, is purely because it's forcing adoption, something that hasn't previously, been really pushed on industry to adopt these software solutions. Generally, we find the best companies always start in a downturn.
So you mean the reverse globalization is better for your for your adoption?
So it's better because people are trying to automate the manufacturing onshore to try and reduce the amount of labor costs. To do that, they need to design parts that are better suited to their current automation capabilities. So that's why vertical integration has become so valuable, because you do have control over the design, you have control over the manufacturing, cost, your lead times, your everything.
I guess, in my opinion,
you could challenge me.
actually, at least when I invest in you guys, I feel it's not necessarily like during the reverse globalization periods, but even like even let's say several years ago, like when the whole world is still globalized, design, sometimes the design is happening in the more like a developed country. Yeah. And the manufacturing is happened, 10,000 kilometers away. Communication, iteration is just take too long time.
Yeah.
You guys can help to solve that problem. Yeah. I guess it's just that in different period, you guys, the applicable scenario are slightly different.
Yeah. So I think one of the amazing experiences you go through when you start manufacturing overseas and moving your development, keeping the design in one place and then outsourcing others, is trying to engage with manufacturers. You end up using WhatsApp or WeChat, taking photos of the models.
That's right.
Instead of people trying to communicate in English or their native language, you just have highlighters. These are the most complex parts that you've seen. And people are basically taking 2D drawings of it and scribbling on it. You try and explain to the other party why you can or can't do these things. And it's that back and forth across, time zones, across geographies, across cultures, across languages that really hampers how quickly you can iterate to a final product. So once again, that's why you need software to provide this instant feedback.
What I see in current, what do they call it? Like
Design for automation?
Design made for order.
Made to order.
Made to order industry, you can see lots of made to order things are standardized, very standardized.
Yeah.
Not everything you can do made to order.
Yeah.
One of the reasons is the design to manufacture is not automated.
No. And that's where you see, why if you get something made at the volume of, 1 million, you start to look at phones, right? They have all of those costs that are incurred with that back and forth, with the design process, with the trial and error. As us, as the end consumer, we're actually paying for that. I think that's something that people really forget is that if you're, buying a skateboard, or there is a certain percentage of that product that was captured by the slow lead times, by the failures in their products, and also by the quality of the product that we receive today. Mm-hmm. So if you can speed up and get hardware to be developed and iterated as quickly as software, I think you'd be in a really amazing place for consumers to get better quality products, faster, more bespoke, made to order. Yep. And that's also what we're demanding these days. The demand for stuff always goes up.
Yep.
And more people want their own, custom phone case. They want things that are quality and bespoke to them. And I think there's been a real shift in the way consumer trends are going. It's away from some of these, mass market. Yeah.
What I see, now AI is a hot topic, but even several years ago, what I see is AI is not just automate some tasks.
Yeah.
And most importantly, is it can bring your idea in whatever ways into a physical product.
Yeah.
And
so that kind of tangible product, and that kind of flow is not only in your area, like the manufacturing, but also, let's say, the drug discovery, material discovery. So that's something, okay, so I have an idea of to solve this kind of a problem, and I have a rough idea this drug could look like, or this biomarker could look like. Then you need to help to discover this physical. This is the same. I have an idea of make some parts. Yeah. And made a draft, and then you need to tell me whether this can be put into a real product. So I guess that's the beauty of the AI can play in the next few years.
And that's what gets, I think, people excited about creating more solutions, is because it's no longer so insurmountable to build or work with hardware. Something that, because I think in a way why we have so many software companies is because it's relatively low barrier to entry in terms of also picking up the skill set and shipping. It's quite different in hardware because you do have to jump through many hoops.
There are so many skills that you need because there's no systems there to support you, right? It's like going back and developing software in the 80s and 90s, right? There wasn't all of these automated infrastructure companies that, in reality, all you have to do is plumb things together. Right? Hardware, you still have to have all of your own expertise.
In the CID, CIM space, in the last probably 2 decades, there are not many.
No, so the incumbents are really good at rolling up companies and stripping costs out and profiteering off it. And there is no incentive for them really to help drive innovation in the industry because they're so large that they've almost got duopolies.
Yeah.
At this point, they're just maximizing for revenue. So that's why startups are coming out more and more in this space, because they have such complexities in their business that they can't really innovate at the same speed as us. One of the interesting things when you're picking up on the automation side, I always like to reflect back on what happened to semiconductors.
Yep.
And one of our mentors is actually an